As I was saying, in lesson 77, we're going to do some more equations that have roots in them, just a little bit longer, a little bit more involved than the ones we have been doing. For example, up to now, we've been doing square roots. This one, we have a cubed root. The strategy is still going to be that we need to get that root all by itself. So I'm going to need to get this cubed root equals. So I bring over the things that aren't part of the root, and they change from negative to positive. So x plus 1, and inside the root, I still have all of that, x cubed plus 3x squared minus 8. And Cooper, I bet you can give me a wonderful guess of how do I get rid of a cubed root? We got rid of square roots by squaring both sides. How do you think we'll get rid of cubed roots? So we cube both sides is the correct way. You had the right idea, teaching the correct vocabulary. At the same time, we square both sides to get rid of a square root. We cube both sides to get rid of a cube root, meaning we raise both sides to the third power. So on the left, that gets rid of the cubed root sign, and we just have x cubed plus 3x squared minus 8. The right side is going to be a little bit more involved because that means x plus 1 times x plus 1 times x plus 1. And we only know how to FOIL 2 parentheses at once. So we're going to have to take 2 of those and get an answer, and then multiply it by the third one. You can pick any 2 you want to do first. I'm going to pick the last 2. So I'm going to keep that x plus 1 that I had on the left, and I'm going to put these last 2 together. I'm going to FOIL those so that I have x squared plus x, so plus 2x plus 1. Everybody with me so far? Okay, then I have to distribute what's in that little parentheses, the x, and the plus 1 times all of that longer parentheses. So if I do that, when I take the x times everything, I have x cubed plus 2x squared plus x. Then I take the 1 times everything, and I have plus x squared plus 2x plus 1. And that is all still equal to x cubed plus 3x squared minus 8. So now we have a whole bunch of terms, and our next thing is to combine all of the like terms and simplify it so that we don't have as much that we have to look at and try to figure out anymore. So I'm going to first subtract x cubed from both sides. So that one goes away and that one goes away. On this right-hand side, do you see that I have 3x squared over there on the right? So I'm going to subtract 3x squared from both sides. That makes this go away, and it makes this combination of 2x squared plus x squared go away. That got rid of 3x squared on both sides. Now, if I put the x's together, they are only on the right-hand side, so they will be 3x, and that leaves me that plus 1 on the right. Let's put it with the minus 8. Let's subtract 1 on both sides. So 3x is minus 9. And then, Austin, what does that mean x is? And so give me a thumbs up, thumbs down, everybody with me to there. So x is negative 3, maybe. What do we have to do on root equations? We have to plug it in and check it. So let's see if I can get enough to where I can see what I had up there at the top. Maybe for the sake of the check, I'll move it down here just long enough to do the check. So we want to plug negative 3 into that original equation. That means I have negative 3 cubed plus 3 times negative 3 squared minus 8, and I'll need to take the cubed root of that, and then minus a negative 3 and minus 1, and I want to see if that's going to equal 0. So what is negative 3 times negative 3 times negative 3, Caleb? Good. Plus 3 times, what is negative 3 times negative 3, Leah? It is indeed positive 9. And then we have the minus 8. And we're taking the cubed root of that. And minus 3 will be a plus 3. And then we have our minus 1. And we want to know if that's going to equal 0. What is 9 times 3? Put that together with negative 27. And we have minus 8. So now we have the cubed root of negative 8 plus 3 minus 1. So plus 2, we want to know if that's 0. Uh-oh, do I get in trouble if I'm taking roots of negatives? That's where I got imaginaries when I was taking square roots. What about a cubed root? Can I do a cubed root of a negative? Wyatt, you're emphatically shaking your head yes. Help me out here. And let's check that out. Is negative 2 times negative 2 times negative 2 negative 8? So yes, odd roots, you can take odd roots of negative numbers. You can't take even roots of negative numbers, or you get into imaginary stuff. So negative 2 plus 2, does that equal 0? So our check worked. So we do indeed accept that x equals negative 3 is our answer on that problem. Thumbs up, thumbs down, or questions? Okay, looks like we're in good shape there. Okay, let's try the other kind of advanced radicals. And that's going to be where we have 2 square roots in there. When we've had one root, we've gotten that root equals, and then we've raised both sides to a power. We're still going to get 1 root equals. But the easier way is if we get the longer one. If one is longer than the other, like this one, n minus 16 has 2 terms in it. That's what I mean by longer. That's the one that I want to get by itself first. So I'm going to say the root of n minus 16 equals 4 minus the root of n. Then I have a root equals, and our method is, we know that we can square both sides, since that's a square root. Squaring it undoes the square root. So our left side is now just n minus 16. So far, so good. Right side we have to be careful on. This means 4 minus root n times 4 minus root n. So we have to FOIL that out. 4 times 4 is going to be 16. 4 times minus root n is minus 4 root n. Inside times inside is another minus 4 root n. And finally, minus root n times minus root n, minus minus is a plus. Root n is a regular n. So I'm going to combine all of the like terms that I can find to combine. I can get my n's together. If I subtract n on both sides, they actually go away on this one. If I subtract 16 on both sides, I have to be careful here. They do not cancel. One was a plus 16, one was a minus 16. If I subtract 16 on both sides, I have minus 32. And then my root n's are all on the same side, so I'm just going to put those together. Minus 4 of them, minus 4 more, is minus 8 root n. Everybody good with that? Okay, now it's pretty much like what we've done before. We have 1 square root in there, and we want to get that square root equals. So we're going to divide both sides by the negative 8 to make this right-hand side just root n. What is negative 32 divided by negative 8, everybody? It is positive 4. What do I do now, everyone? Square both sides, and maybe n is 16. But we're going to have to do a check on that. So let me get my equation again where I can see it a little bit more easily to plug 16 in and check. And I'll label that I'm doing my check now. So 16 minus 16 inside that square root, just a 16 inside that one. Does it equal 4? Well, 16 minus 16 is 0. What's the square root of 0? 0. What's the square root of 16? Does that equal 4? So it works. So we accept that n is equal to 16. Now, I was asked an interesting question last period. It's actually a very good question and a mistake that it's very easy to want to make. And so I just want to clarify that with you. You cannot say, oh, I'm just going to square both sides and say that that means n minus 16 plus n is 16. Because of this plus in here, this does not work. You've got to have just one square root. What I just wrote here would mean root n minus 16 plus root n times root n minus 16 plus root n. So then I'd have to factor it out. That would give me a regular n minus 16. But then I'd have root n squared minus 16n. And then I'd have another root n squared minus 16n, and those would not cancel. And then I'd have plus a regular n, so I'd have an even bigger mess than I had before to try to work with. No, you're going to run into too many problems trying to do it like that. The big deal is this does not work. This would be a valid step, but it's going to be too messy. You're going to get too many weird steps in there to try to solve, and you're going to get stuck. So just making sure if it's not just one square root, you can't just undo that by squaring it all at once. That's what I wanted to point out. So does that point make sense to you of what I'm cautioning you on? Okay, one last example for the day. Once again, I need to start by getting a square root all by itself. So, Kit, which square root should I get by itself? I said get the longer one by itself, so which one's longer? So we're going to start with root a minus 8, because that's the one we want to get rid of first. So we've got a simple one at the end, just root a to deal with. So that means 2 minus root a. And what is my next step, Ethan? Exactly, I have to square both sides, which means on the left I have root a minus 8. Similar to what I was just talking about is 2 minus root a. When I square it, is that 4 minus a? Did I do that right? Nicole, you're correctly shaking your head no. What did I do wrong? So I have to multiply. Thank you. I'll get that other one fixed in a moment. I have to multiply 2 minus root a times 2 minus root a, and fixing the typo, or whatever you call it, when it's handwriting. Over here on the left-hand side, when I squared root a minus 8, the square undid the square root, so I did have just a minus 8. I accidentally wrote the square root down again. Everybody have that fixed in your notes? Okay, so this is not going to be 4 minus a. It is going to be 2 times 2 is 4. So yes, I do get a 4 in there. And then I have minus 2 root a, and I have minus another 2 root a, so minus 4 root a, and then minus root a times minus root a is plus a regular a. So I had that extra minus 4 root a in there that I was skipping when I was doing it the wrong way. Now I need to combine like terms so I can get rid of the remaining square root. Subtract a from both sides and those go away. Let's subtract 4 from both sides. And we have minus 12 is minus 4 root a, I believe. So if I want root a by itself, divide both sides by negative 4. Allie, what is it? What is root a going to be then? So root a is 3. Emily, now what do I do? And get, so maybe a is 9. What do we still have to do? Still had to check it. So let me grab the equation and get it where we can see that. And let's try to plug 9 in. So 9 minus 8 plus root 9, does it equal 2? Root 1 is how much? And what's root 9? And what is 1 plus 3? And does 4 equal 2? It does not equal 2. So it is not a solution. So no solution. Question. I could, but that would give me a negative 1. Does 1 equal negative 1? So, I mean, there are a couple of ways I could have gotten to that contradiction in there. But either way, I get something that's false. All right, let's get ready to do some homework.